Hello, good morning, students. Okay, so we are going to proceed with lecture 19, new chapter 6. But before we proceed with lecture 19, I think it's good if we can have a short review on filters. Okay, these are the things that we have learned in chapter 5, just to have some short review on this. Uh, So we have learned about the orders of the filters, in our lectures before, and I did mention in my lectures that our syllabus will only concentrate on the first order type of the filters. So that is why in our lecture 5 before, we just concentrate on a first order type of low pass filter and high pass filter. And we have learned that the low pass filters and high pass filters can be obtained from the RLC circuit, okay, depending on which output that we, I mean, which device, whether it's R, L, or C, that we choose to take the output or the voltage output of it. Yeah. Okay. So this will be okay. These equations are the equations for the transfer function or the common transfer function. For instance, if we have a low pass filters, the transfer function will be Hs of A over S plus B, where A and B, both of them are constants. And if we choose, if we go for the high pass filters, the transfer function will be S over S plus C. There should be 1, 0, and there should be one pole, yeah? So we can see that for the first order type, for both low pass filters and high pass filters, we are supposed to have one pole only, yeah, for the transfer function. Okay, so this is something that I've not taught, I have not teach in class before about the second order and higher order filters, but I'm going to just we just have a short review on this. Yeah, a second order and higher order will be applicable for this kind of filters, which include the low pass filters, the high pass filters, the band pass filters, and the band reject filters. Yeah, so it's applicable for these kind of filters. And for the first order, is only for the low pass and high pass. Okay, for what is the difference between the second order and higher order type as compared to the first order? So the difference between these type of filters, second order and higher order, and the first order will be on the number of poles. Yeah, number of poles. So if we consider a second order type of filters, whether it's a low pass or high pass, band pass or band reject, we are supposed to get two poles in the denominator. Yeah, so if it's third order filters, we're supposed to have 3 poles. If you have fourth order filters, you are supposed to get 4 poles. Yeah, so that should be the difference that is obvious between the first order and the higher order filters. Okay, so I hope by this you understand what are the differences between the first order type and the second order and higher order types. Yeah, which will be determined solely by the number of poles, yeah, in the denominator. Okay. All right. So let us proceed with lecture 19. So lecture 19, which is a new chapter, chapter 6, which will be our last chapter for this course. So lecture 19, we're going to proceed with a special filter type, which is called a Butterworth filter. Okay, so this is the extract from the course information, in which for this chapter 6, we are supposed to learn about the Fourier analysis for continuous time systems and the filter design. And we are going to concentrate on two types of filters, the Butterworth and Chebyshev. However, for this semester, I'm going to concentrate only on the Butterworth filters. Yeah, right. For the Butterworth filter, I'm going to concentrate only on this kind of filters. So for the Chebyshev filters, it is taught in lecture 20. Yeah, but I'm not going to cover these Chebyshev filters for this semester. So if you are interested to learn more about Chebyshev filters, you are most welcome to learn it on your own. Yeah. So this Chebyshev filters is in lecture 20, but I'm not going to cover these topics. Yeah. So our concentrate, our main emphasis for this lecture 19 or for chapter 6 will be only on the buzzwords filter. Yeah. Okay. So this is a revision, things that we have learned so far from chapter 5. Yeah. So in chapter 5, we have learned about these 7 important things. The importance of filtering and its application in electrical engineering field. Yeah. So we have learned about this importance of filtering. Number 2, we have also learned about the types of filters, which include the active and passive. And as I mentioned, our syllabus will only go for the passive filters, which consists of a circuit, electrical circuit of R, L, and C components. Okay. And then we also learn about the low pass filters, the filtering ability, low pass, high pass, and for the band pass filter and band reject filter, this you can learn on your own on lecture 18. Yeah, so we concentrate only on the low pass and high pass filters. Okay, and for the filters term, yeah, we have learned about the 3 dB bandwidth. Yeah, we also learn about the cutoff frequencies. Yeah. And then I've also taught recently on the filters order, the first order and the second order, and the difference between them. Okay. And finally, this is the most important things in chapter 5, where we have learned how to plot the filters frequency response, both the magnitude and phase, by using the board plot, or board sketch. Okay, so these are the things that we have learned in chapter 5. So for this chapter, these are the things that we're going to learn in chapter 6. Number 1, we are going to classify the passive filter type based on the magnitude plot. Okay, so as I mentioned in the first page of this lecture, we are going to concentrate only on the Butterworth filters. Okay, so we're going to see how we can classify the Butterworth filter by looking at the magnitude plot. Okay, number 2, we are going to understand the important parameters in the designing steps of the Butterworth filters. Okay, so number 2 is quite important because we have to understand what are the important parameters that need to be obtained in order for us to design the Butterworth filters. And number 3, we are going to design the Butterworth filters based on the given specifications. Okay, so basically these are the important things to be learned in chapter 6, in which our concentration will be only on the Butterworth filter. Yeah. Okay, so this is about the Butterworth filter. Basically, the filters is invented by a British, by a British engineer, Mr. Stephen Butterworth. Okay, and it is designed to have the magnitude plot which is as flat as possible in the passband. So if we can have a look at this magnitude plot, we can see that in the passband region. So this is considered to be a magnitude plot for low pass filters. Yeah. So the magnitude plot in the passband is said to be as flat as possible. Yeah, it's going to have a flat magnitude response at the passband, and we're going to have a slower roll off towards the stop band. Okay, which means that the stop band side here, the roll off is slower, which means that the slope, the slope of this particular line is not that steep. Yeah, it's not that steep. So it can be said that for the Butterworth filter, it is good to have in terms of response. It is good because we have a flat passband. However, in terms of the frequency selection process, it's not that good because the roll off is lower. Roll off is lower. So in terms of selecting the frequency, you're going to have a problem on that issue. But the advantage of these filters is a flat magnitude at the passband. Disadvantage of it is the slower roll off for the stop band. So that should be the advantage and disadvantage for the Butterworth filter. Okay. Right. So these are we're going to proceed now straight away to the designing techniques of the Butterworth filter. Okay, basically in the process, or procedures of Butterworth filter design, these are 3 important things that we're going to do Number one is to determine the filter order based on the given specification. Okay, so we're going to obtain the order of the filter based on the given specifications. Number two, we are going to calculate the actual cutoff frequencies. And number three, we are going to determine the transfer function of the filter. So these are three important things that need to be obtained. Yeah. Number one is the filter order. Number two is the cutoff frequency. Number three is the transfer function. Yeah, transfer function. Okay, so I'm going to stop here. So in part 2 of lecture 6, lecture 19, sorry, part 2 of lecture 19, we're going to proceed with the process design of the Butterworth filter. Okay, thank you. See you after this.